Hi friends, today's lesson is about scale drawings. Watch the tutorial about scale drawings on your Pearson Realize online account. Now go through your books, page number 415 to 420. Answer the given questions. This lesson, mainly we are going to talk about enlargement, scale factor, reduction, scale, proportions, scale diagram or model. Model, representation of something else, usually too big or too small to analyze easily. Enlargement, to make something bigger so that one can analyze or observe the details. Reduction, to make an object small so that one can observe or analyze the details. See, in mathematics, scale shows the relationship between two things as well. With maps, it is usually between a distance measured on the map and the actual distance on the ground. We can use this formula: map scale equal map distance over ground distance. Friends, now let's check where we'll apply this situation of the scale drawings in daily life situations. We know about scales at the supermarket. They measure weight. They show the relationship between how much you are buying and how much you have to pay. A scale drawing represents something that is too large or too small to be drawn at its actual size. Maps and blueprints are examples of scale drawings. All scale drawings must have a scale written on them. Scales are usually expressed as ratios. Normally, for maps and buildings, the ratio will be like this: drawing length is to actual length. For maps, the ratio is normally in the ratio map distance is to actual distance. Example, 1 centimeter is to 100 centimeter. The ratio 1 centimeter is to 100 centimeter. The ratio 1 centimeter is to 100 centimeter means that for every 1 centimeter on the scale drawing, the length will be 100 centimeter in real life. Another example, 1 is to 10,000. The ratio 1 is to 10,000 means that the real distance is 10,000 times the length of one unit on the map or drawing. Now we are going to learn about scale factor. Scale factor is the ratio of change. The number you multiply by to relate the first shape to the second is the scale factor. The scale can be written as a scale factor, which is the ratio of length or size of the drawing or model to the length of the corresponding side or part on the actual object. Scale factor must be the same units. A scale is the ratio between two sets of measurements. Scales can use the same units or different units. The photograph shows a scale drawing of the model train. A scale drawing is a proportional drawing of an object. Both scale drawings and scale models can be smaller or larger than the objects they represent. Remember, there is more than one way to set up a proportion correctly. Cross multiply. Use common sense. You can find this all. Scale drawings. What are scale drawings? Scale drawings are everywhere. Look at this picture. Can you think of any more? Look at the example of scale in everyday life. This is a kitchen design. You can find its length and length of the unit. The scale is the relationship between the measurements of the drawing or model to the measurement of the object. Look at this beautiful van. In real life, the length of this van may measure 240 inches. However, the length of a copy or print paper that you could use to draw this van is a little bit less than 12 inches. Am I right? Map scales. Ratios and proportions can be used to find distance using scale. Look at the given map. The scale of this map already provided 1 inch equal 15 miles. So look at the example. The distance from Riyadh to Dammam on a map is 4 inches. How many miles are between these cities? This is only an example. Look at that. We can make a proportions. 1 inch over 15 mile equal 4 inch over n. From here, you'll get the distance between the two cities is 60 miles. Suppose the distance between two cities is about 4.1 centimeters on the map. So what is the actual distance on the ground if the scale is 1 centimeter equal 4.5 kilometer? We'll use this formula. So first use the scale as a fraction, 1 centimeter over 4.5 kilometer. That should be equal 4.1 centimeter over x kilometer. Then we'll use the cross product to calculate the value of x. X represents the distance, so you can say distance equal 18.45 kilometer. Now, width of the pool on the blueprint equal 1.75 inch. How can you use the cross product to figure out how wide the pool really is? We'll use this method and you will get width of the pool equal 14 feet. I can solve problems using scale drawings. Yes, if you know the actual length of an object and you know the scale, you can build a scale model. Scale models are used to represent things that are too large or too small for an actual size model. Examples are cars, planes, trains, rockets, computer chips, heart cells, bacteria, etc. Things to remember: when solving proportions, give your answer in the correct unit of measurement. Scale factors do not have units. Equivalent scales have the same scale factor. Scale is the ratio between the drawing or model measurement to the actual measurement.